Our next session is retrofitting legacy applications for AI. I'm joined again by Jeff. Hi, Jeff.
Hi.
Jeff joined Synergex in 2006, bringing with him his passion for open source and standards-based technology. His first major contribution was Synergy DBL integration for Visual Studio. Over the years, Jeff has led the development of innovative solutions that help our customers modernize while maximizing their existing investments, including support for .NET, web services, and streaming integration. As the technical lead at Synergex, Jeff drives the company's technology strategy, ensuring synergy-based software remains competitive in a rapidly changing technical landscape. Jeff is going to share how Synergex is shaping the future of enterprise DBL applications to seamlessly integrate with AI technologies. Let's get started.
Hello, and welcome to Retrofitting Legacy Applications for AI. My name is Jeff Greene, and I am Synergex's CTO. And we're going to cover how you can prepare your applications for this sort of world of AI that we're on our way into. First off, what is AI actually good at? Because there's a lot of people that use AI for things that maybe it's not good at or not good at yet. And then there's different sort of categories, and knowing where you might fit in that and knowing what options are available to you is probably going to be pretty helpful. So some AI strengths, sort of categorized into data science / ML, kind of traditional older style AI, and Gen AI, the sort of thing that you think of when you think of like ChatGPT or something like that in your browser, where it is generating text in response to something that you have prompted it with. So data science and ML are really good at categorizing and interpreting structured and semi-structured data. So that is recognizing patterns, that's sentiment analysis, that's looking for things like fraud. You would use a data science kind of approach when you're trying to solve one of those problems. Pattern recognition. So you'd be conceptually looking to see, do people always do this same thing at this time of day, or whatever your pattern is, whatever problem you're specifically trying to solve. Oftentimes you can categorize it into these pattern recognition type things. And finally, if you're providing support for decision making, data science and ML can be, again, really helpful. Those are under sort of the guise of statistical analysis, but it becomes data science because you're working on a much larger data set than just doing a little bit of statistics in Excel or something like that. So Gen AI, that's where kind of all the hype is. What is it actually good at? It's really good at writing Python for you. If that's the problem you're trying to solve, it's pretty effective. It is very good also at providing a textual interface that reduces the difficulty of sort of complicated interactions. So you can think today in complex line of business type applications, you might have like a search page or something like that. And rather than having freeform entry, you kind of break down that search into little boxes, and they have to know exactly which box to fill in and which drop downs to pick in order to get the query just right under the hood. Whereas the idea for providing a textual interface via Gen AI is really one more of, I'm going to give you this natural English language query or whatever language you're supporting. And we're going to just figure out what you mean. We're going to get close enough, and we're going to return back approximately what you're looking for. So it's those imprecise tasks. The key there is they can't be precise tasks. They have to be tasks that allow for a little bit of wiggle room on the side of interpretation. GenAI is also excellent at generating authoritative sounding text that may or may not have any resemblance to reality. So watch out for that. Just because ChatGPT has generated something for you, or you've called the API and you've generated something for a user, does not mean that what it has generated for your user is true or likely to result in a good outcome for your user's use case. GenAI is also excellent at liberating venture capitalists from their capital. The market can stay irrational for a very long time, and we'll see how that turns out. So if you are trying to feed one of these AI pipelines, there's a couple of different things that you need to be thinking about when you're thinking about your application, how it exists today, how it will exist in the future. So if you are trying to do pattern recognition, categorizing those traditional data science-y kinds of tasks, you are best served by doing bulk extracts from your production data so that you can take that big bulk thing of just plain files that are standard and readable, and you can hand it to some kind of analysis pipeline, and out pops whatever your answer. The other option is you can stream the change data capture data. So that is the ongoing data that is happening in your environment. So every time there's a change, you get another record that says this change happened. That's different than a bulk extract. That is potentially going to enable your pattern recognition to operate at an event level rather than I'm going to process all of the data in the world and give you an answer. Processing it as events occur gives you a different kind of pattern that you can recognize. But still, the data in that change data capture pipeline needs to be standard and readable. The other thing that you need is well-formed and complete sets of patterns to recognize. So if you don't know what you're looking for in data, you aren't going to be successful here. So there's the idea that you can be experimental, but you probably, before you make it all the way into production, before you do the heavy lifting of productionalizing your data pipeline, you probably need to have some idea of the kinds of questions you're trying to answer with this AI or data science-y pipeline. So if you don't know what you're trying to solve with it, you're likely to get distracted by things that are either only present in the data that you're looking at, so like a false pattern, or just doesn't serve a business purpose. So whenever we're building AI doodads, we need to keep in mind we are actually trying to deliver functionality to users, to the business users internally who are trying to consume that data, make decisions, plan for what they're going to do next. Whatever your particular use case is, you need to have figured it out before you start down this path. And that's especially strong in the decision-making support, because how would you tell someone how to make decisions if you don't know what kind of decision they're making? But it applies throughout the rest of this conversation. So you will need standard data schemas, and there's different ways to provide that. So I'll talk about how repository helps with this later on, but approximately the idea is you get your data into one of the data frame compatible formats, or CSV or JSON, and anyone anywhere now can consume your export or consume your change data capture. And that makes it so you're not looking for a DBL resource that is a ML expert. You're now looking for someone that knows how to use data sciencey stuff or Gen AI stuff without having that added modifier that they have to understand how DBL data is defined. And you're also going to need some sample data. So sample data is not actual production data with important PII on the inside of it. That's probably not a great way to fill your sample data. And it's not so small and so isolated that the code that you're running against it has a pretty solid chance of picking up the wrong signal, right? Like if your sample data is completely non-representative of the production world, you're going to have a much harder time validating that the pipeline you have built is actually useful and does solve the problem that you're trying to solve. So what the heck is this change data capture? How do you get bulk extracts? So we've been pushing. We're pushing harder. We're going to continue pushing even harder. That externalizing your data is healthy for your application. So in this case, as Mary Poppins is saying over there on the side, just a spoonful of AI is going to make these reasonable infrastructure improvements go down. So you're providing your management with a good reason. They're going to get something out of it, and you're going to get something out of it. At the end of the day, if you externalize your data, you're going to be able to position yourself for using that data in Gen AI or data sciencey type stuff, even though you're not actually having to do AI parts right there. Like you're just making it available so that AI stuff can come in and be useful when you're ready to do that. So this is the pre-work portion. So how do you externalize your data? So we're pushing for Kafka, and we use Parquet for bulk data. So Parquet is just it's a columnar data storage. So it stores them in big chunks of each column in your data, and it's really fast for analysis work, and it's very compact. It's not for like operational data. It's not for random, read-write kinds of access. It's really just an efficient way to collect all of your data, dump it out somewhere into a standard schema, and then allow people to read it and do analysis work on top of it. And Delta Lake is basically just ongoing Parquet. So it's you imagine you start off with one bulk export, and that's the Parquet files, and then Delta Lake is the ongoing. Here's some more change. Here's some more change. Here's some more change that gets laid on top of that. So it's really helpful for blending those sorts of batch worlds along with the streaming world. So why are we externalizing your data? Operational databases like ISAM or Microsoft SQL or whatever you're using, they're busy doing operational things. And the analysis workloads that we're really talking about here for AI stuff, they're potentially large workloads that you don't really want to put in the same place as your users, right? Like your users would notice if the system was running 50% slower than normal today. Whereas for these kinds of non-real-time tasks, no one would care if it was a little bit slower. But the idea is that you separate those heavy lifts that are not real-time from your real-time operational system. So getting data out of ISAM in a standard format or out of Microsoft SQL again in a standard format makes that a reality. So take this opportunity while your management is probably thinking of, our executives are often thinking of, how are we leveraging AI within our software stack? This is a good moment, a good leverage point for you to move forward your data strategy. So moving towards that high availability and disaster recovery kind of world that also comes along with externalizing your data. And regardless of where AI initiatives end up in the future, at the end of this, you'll be better positioned for whatever is the winner in AI, and you'll be much better positioned in terms of how your application manages data in general. So just a little bit more in depth now on specifically why we push so hard for Kafka. So we want to really be able to replay past events over and over and over again. So if you're familiar with AI, they are, depending on how you look at them, they're kind of random number generators. And they operate within kind of a bound. And if you are trying to develop your prompt, or train your model, or whatever the heck it is that you're trying to do, you're going to need to be able to replay the same scenario over and over and over again. And once you get into a production environment, when things go weird, you're going to need to be able to replay those events that made things go weird over and over and over again. So we're not talking about a messaging system that broadcasts out to all of the listeners. We're talking about a durable store of the events that have happened in your application's data. So that's one big reason. Kafka, by its nature and its ecosystem, tends to be highly available and has an excellent disaster recovery story. So if you are relying on Kafka as your sort of source of truth for data, you don't have to worry about what happens if the power goes out in one of the racks in a data center somewhere, because you've set it up such that your Kafka cluster keeps on running, doesn't lose any data. The other very specific thing about Kafka that is not always true for all event-based systems is that ordering is maintained within the partitions. So we can reliably say we're going to get this same sequence of events back out as what we put in. So if you imagine the operations that happen in a inventory environment, the actual subtraction of items from your available inventory will happen in the same sequence of events, and so you can't end up in some different scenario where when you do the replay, it looks like someone else should have gotten that item, whatever the deal is. You keep that ordering, and it makes it a lot easier to reason about your application and how data is moving through it. Latency is very low in Kafka, and throughput is very high. So these two things are often at odds, but in the broader Kafka ecosystem, these get brought together, and we end up being able to process messages very quickly, and we're actually able to process them in a very sort of wide fashion. So latency is low, throughput is very high. A big win is that it is accessible outside of the Synergy ecosystem. So we're not selling you some proprietary Synergex thing. We're talking to you about something that exists outside the world of Synergy. And that lends into being sort of enterprise executive friendly architecture. So you can have a conversation about, we're moving to a Kafka-based eventing model, and enterprise architects can have thoughts on that, and without having to think specifically about Synergy. And externalized inputs can be tied to their outputs. So if you take this to its logical conclusion, events roll into your system, complex business logic happens, and the results pop back out to the outside world. Intermediate steps there are requests come in to a RESTful interface, and you add a correlation key that flows through the rest of the system. So you can come back and say, someone made this request on our API, and it resulted in these changes to the system. So doing this enables sort of these very interesting, safe system migrations that are in flight. So if your inputs are replayable and you can check them against their outputs, it means that you can rerun those inputs and recheck those outputs and have the production version running and a test version running where you're verifying, like, does my application still operate the same way in version 2 as it did in version 1? And you can actually check and say, this is what came in, and what came out was identical. Therefore, it's good. So this allows you to do verifiable deployments in production. So you're operating on the sort of live transactions, but you're not impacting actual production. And my lovely little meme picture here is it serves as a little bit of a double entendre. We're pushing it so hard, flipping the Jeep up, but also they are changing the tires on that Jeep while it is driving. And that is actually a real photo. They change all 4 tires on that Jeep. And that's kind of what having externalized inputs can kind of allow you to do in those sort of safe system migrations. So some more concrete things that you have to think about as you're moving from the data that you actually have today into how do you prepare it. So if you get to the data externalized, and it just is externalized somehow, what do you do next? So clean data is happy data. Cleaning your data is the most important part of data science. It's the worst part of data science, and it is the most important part. So CodeGen and repository can help you here quite a lot. So today, if you were to just dump all of the data in all of your Synergy records out to a CSV file, no one would really know what to do with it, probably. If you included the sort of schema, so you have all of the field names and some data types somehow, they probably still wouldn't know what to do with it. I've seen more than a few JLCTIM variable names kicking around in people's records, and that means something to you all deep in the bowels of your software. But it doesn't really mean anything to people outside of your very immediate correspondence. So what repository lets you do is you can specify alternate field names, and those will be used by CodeGen. So they won't impact how your code is written. They don't change anything to the compiler, but they do make it so that CodeGen knows that this field is actually the count of available rooms or the total inventory available or whatever the heck that field is. It has a human readable, human understandable name that goes along with it, and maybe even a description. So CodeGen can use that. So if you end up writing out to Parquet or something like that, CodeGen will know the data types, the human-friendly name, and generate code appropriately to map your Synergy records into that standard format. Important, useful thing, avoiding untagged overlays. So if there's no way to determine which layout applies to a particular record, it gets very hard to reliably produce that data. So a tagged record is one where you have in a file 3, 4, 5, 10 different record subtypes, and the layout might be completely different between a inventory master record and an individual inventory record. And so you put in a letter M and a letter I in character position 3, wherever it is. You've put this tag field, and that makes it so that when we do that extract, we can look for that tag and say, oh, I know how to interpret this record data. I'm now going to produce the correct structure output. And so I will have integer data where it belongs, decimal data where it belongs, and alpha data where it belongs. And that makes it actually usable. If you have untagged overlays and there's no way to pick which layout is correct, you end up having to put out both. And so you end up with a whole bunch of extra duplication and a lack of clarity when the consumer of that data should pick one set of fields or the other. So things kind of spiral a little bit out of control when you're trying to communicate how they're supposed to make that decision without tags. Other important things, removing duplicates and resolving conflicts. So in a lot of cases, you might have production data that's been kicking around for a very long time. And at some point, 15 years ago, there was a bug that wrote a bunch of records in the front of the file, and no one ever looks there simply by construction, right? Like your code just never goes there. But if we go dump the entire contents of that file, it's going to be in the dump. So if you have invalid data that does not match any of your tagged overlays, for example, or has just invalid data interspersed in it, like corrupt binary data or whatever, because someone wrote it wrong, this is going to show up really evident to anyone who's trying to process the entire file. So your AI or ML pipeline, whatever, is going to run into it, and it's going to choke on it. So be aware that the data in your files needs to actually be valid, not just logically valid, but specific data types have to actually be in there. And if you don't, it won't work out well. So some other specific places that this might, you might run afoul of this is everyone has their own special weird date time formats that ultimately need to end up mapped into a standard format. So when you encounter that field, that A8 or D8 or whatever it is that you have, we have to know enough from your repository to be able to convert that, run in maybe some special code against it, and get it into a normal Parquet format or a normal SQL format, whatever it is your end destination is. So things to be aware of. When you actually go to run this, you're going to detect and you're going to have to correct outliers and anomalies. And it's important to realize that there's two options whenever you run into one of these. It's that it might be real, might be real valid data, or it might just be incorrectly mapped data. So this could be a real problem that you just weren't aware of, or you just need to change how it's defined in repository, and then you'll smooth it over and fix it. And finally, Gen AI and some Python greatly improve your quality of life in this cleaning phase. So whatever problem you're trying to solve here, you can probably describe it to ChatGPT or whatever. And because it's an expert in writing Python, and Python's pretty good for data cleaning, you can solve tons of problems very, very quickly without entirely having to understand the details of how that's getting accomplished. All right, so now we're gonna talk about actually applying a little bit of AI. So this is a relatively realistic application of it. Originally, Rachel said, "Hey, Jeff, I want you to come up with some kind of content about AI and do a presentation about it." And I was like, "Oh, what am I going to do?" And then someone started talking about a real problem, and I was like, I can actually fix something, and I'm not just making a weird demo for the sake of making a demo. So I like this because it's real. So imagine you're maintaining some resort management software, and there are a lot of entry fields in your UI and in your data that are sort of semi-freeform text entry. And users, while they are not always the smartest, they are frequently very clever, and they will figure out how to get their job done, regardless of how you intended them to get their job done. So if you look really closely at the screenshot, you can see they are using guest names to store financial PII information. This screenshot is not actually real financial PII information, but this was a real problem that we really did see. And how can we apply some AI to try and solve this in a one-time fashion? And how can we potentially adapt that to solve this problem ongoing? So steps that we performed here and tools that we used. So first off, we're trying to scrub this PII, right? Like this can't exist here. There are actually encrypted fields that are supposed to be used for this kind of information in this particular application. And so when the users dodge those fields, they are putting this sensitive data in non-encrypted fields. So we need to detect this so that we can get rid of it. And we want to be able to ongoing potentially detect it later on. So we take a snapshot using the snapshot agent from the integration platform that produces standard Parquet files for the data that we care about. So now we have in our standard format, We then identify the interesting fields. So there's in this particular application, there's just a couple of fields that we're really worried about. And so we pick those out. And then we correlate and format the multiple record types and the files that need to be scanned, let it run for a while, and ta-da, out pops our answer of here's all the bits. So to do this, we used a library called Pandas. We use it from Python. I generated this Python entirely from ChatGPT. It was pretty easy. It was my third attempt at it before I got it right, but it wasn't that hard. And we're leveraging a piece of open source from Microsoft called Presidio. This is kind of a blend of traditional recognition and sort of MLE type recognition. So the way it works is it starts off with a regex, and then it moves into these sort of named entity recognition and natural language processing models to do further refinement. So rather than trying to apply an LLM to a whole bunch of records to like gigabytes of data, which would be very, very exceptionally slow, it finds the interesting parts and then it applies the model to it. So this, we run this entirely local in our use case, which is a pretty good recommendation when you're dealing with PII in particular. You don't really want to be sending that off somewhere else to get processed. And this works best when you let it recognize everything that it's capable of recognizing and not just the very specific PII types that you are interested in. So if you let it recognize everything, as an example, it won't incorrectly think that a phone number is an Australian social security number because they look kind of the same, similar. And if it's not recognizing the entity type, then the model is it just thinks, well, the nearest match for this is, I think it's this kind of PII. So let it recognize all the entities that it's capable of, and you'll get much better accuracy out of it. And here is an actual demo of finding that stealth PII. So what we have here initially, the way we convert from Synergy data types and Synergy records into something that we can use in Parquet or anywhere else for that matter, we have these mappings. These are what drive a lot of the integration platform. So you have the fields themselves and information about the record and whether there's subtables. There's support for things like match expressions to deal with tagged columns where you have multiple record types in a single file. So in this particular case, we are processing a comments ICM file that has two different record subtypes in it. And so we're going to export that using the integration platform snapshot agent. So I have a pre-set up command line here, but basically I'm running the snapshot agent itself. I'm setting up some environment variables to help the engine map down to where ICM files actually live. I'm telling it where the configuration file is that we looked at earlier, and I'm telling it where I want the output. All right, so it is a 400 megabyte ICM file, and it's telling us that it found one error while it was mapping the rows. And that is because in this particular file type, there is a incorrect first row in the file, and it contains nothing but white space. It isn't identified in the repository, so we don't handle it as a separate record type, but it is effectively a separate record type. So in this particular case, we have ignored this first row because there was bad data in it, but then continued the processing. And you can see it took 3 whole seconds in order to process this 400 megabyte ISAM file. And it has produced a pair of Parquet files, one for the header subrecord type and one for the items subrecord type. All right, so that's how we get the data from ISAM files. What are we going to do with that data? So we've got a Python script here, and its purpose in life is to bring together a bunch of components and open source libraries from the internet. So we're using Polars and Presidio primarily, and we're slightly enhancing Presidio and saying, I'm really interested in this particular credit card pattern, so use it to do some initial filtering. So Presidio as a concept is a combination of regexes and search mechanisms for like plain deterministic operations combined with, it's not exactly a large language model type thing, but it's got the same kind of underpinnings, but it's a technique called named entity recognition. So it's running an AI model under the hood and processing the nearby text. So when there's a hit on a regex or one of these other find mechanisms, the named entity recognition comes in and says, is this actually what the regex is telling me it is? And it comes up with a confidence interval, and we get to use that confidence interval later on to decide if we actually want to recognize this as a piece of PII. So we do some setup here, and we tell it what we're after and what patterns this applies to, and a little bit of context around if someone says one of these things nearby, this might be a pattern that's interesting. So on to actually processing the comments. So we take in a pair of Polar's data frames. It's not super important. Think of that as like a Python data table if you're used to like ADO or something like that. So each one of those is a data table. We're going to combine them, set up the types of entities to detect. So we're going to pick all of the different entities that we could possibly see. And we're going to pick which ones we actually want to keep. So we're attempting to identify all PAI types, even though we're only looking for a couple. This is to improve the quality of the named entity recognition. So when it gets to choose between a address and a credit card, it does a better job of deciding that this is not in fact a credit card when it looks too much like an address to be a credit card, as an example. So that's why we recognize as many types as we can, rather than just the ones we're after. So this one line here on line 40, 41, and 42 is kind of where most of the Polar's magic happens. So we're combining and sorting and grouping by all at once. So we're taking the headers, they have their primary keys, and we're combining them with the items from the items file, the comment items, and then grouping by that primary key and combining all of the comment text together. So there might be 10 or 15 records for a single comment because there's only 120 characters per record. And this combines them all and puts a little white space in between them and spits it out so that we can process it down here in the actual Presidio analyze. So we open an output file because we're gonna dump out a bunch of JSON as our results, and then we start processing the batches. So we read in a couple thousand rows at a time and send that off to Presidio. Let it do its processing. We get back the results of a batch. Decide, is this something I actually want to keep? Is this an entity of interest? And is the score that came back from the model, is it telling me that it is greater than 0.5 on a 0 to 1 scale? Is it greater than 0.5 chance that that it is the named entity we're after? And if it is, then we're going to include it. And if it isn't, then we don't think that this is it's probably not PII. So we take that and we build a JSON output, and then we dump it to a file. And that's the whole deal. So it's not a whole lot of lines of Python. There's just a little bit more in this file to actually print out, like command line help and stuff like that. But the meat of it is really just this one function, process comments. So with that, I will go ahead and run it. So this one is set up for demo data. And so it's going to go really, really fast because I don't have 400 megabytes worth of demo data. But we will run this Python script. And it scans and it tells you how many batches per second it iterated. And out that pops, and we have our PII report. And so this is the JSON that we were instructing the Python to output. And it has found the records where it thinks there is credit card information in one of the comments. So we know from its primary key, we can go look that up and validate it as humans. We know in which comment sequence it is. So this is the header is 0, and then each subsequent 120 character chunk is another in the sequence. So this is the third one. And it tells us where in that record this actual PI occurred. So it's in position 5 through 21 of the third comment sequence. So with that information, we could go and remediate that PII that doesn't belong there and attempt to figure out how it got there in the first place and prevent that in the future. So this demo is showing you basically batch work. So we're taking whole files and we're dumping them out and processing them. And that is the most efficient way to just blast through a pile of data that you have to get through. But you can use the same techniques, the same mappings, the same integration platform parts and pieces to stream your data and collect that streaming data in little micro batches, and you run Presidio against those little chunks throughout the day. And that the purpose of doing it that way is so that you can see when the PII sneaks in, and you can potentially tie it back to the event that caused that PII to get there. And that makes it a lot easier to go talk to the person that put that there or the process that put that there incorrectly and deal with it. So the closer to the event you are, the better off you're going to be. So that is one way to detect PII data in your Synergy data. Well, thanks for going on this journey through modernizing legacy apps for using AI and streaming in particular. Who has the first question?
All righty, back at it. Well, I'm not seeing any questions in the chat, so don't you worry. I've got some myself. So Jeff, you emphasize Kafka for data externalization. How do you balance Kafka's strengths with the complexity it adds to smaller or mid-sized organizations' infrastructure?
Yeah, so I'm mostly at this point of the opinion that a single node Kafka setup that potentially runs in the same place as the rest of your application, if you're already working in that sort of single node environment, that doesn't actually increase the difficulty of deploying particularly. So like if you choose Red Panda as your way to do Kafka, it's just like a single binary, and you set it up and you run it as a service, and it's there and it's running. And all of the complexity is around how to effectively do this, high availability kind of environment. So if you're small to medium sized business and you can't deal with the complexity of high availability, you can still get Kafka and you can still get some of these availability improvements, and you can externalize your data and send it other places. But you don't necessarily have to bite off the whole chunk that is, I'm going to run 3 high availability separate nodes of Kafka and do backups to an offsite location. Like, if that's not your environment, you don't have to go all the way there. So probably that's the answer.
I have one more question. How do you convince business stakeholders that externalizing data and introducing tools like Kafka isn't just a technical exercise, but a strategic investment in long-term flexibility?
So we're at this moment, and I mentioned it in the presentation, but we're at this moment where executive leadership everywhere, like across all segments of business in the world, are pounding on this drum of how are we using AI effectively, and how are we doing these things, and what's our improvement here. And it opens up a lot of opportunity for us to say, we're going to try and service that question that you're asking about AI. We're going to build this thing so that you can answer those questions and do those things. And that's our hook, right? AI is the hook. What we end up actually delivering is AI. If AI is valuable for your use case, you can deliver that on top of this. But we also deliver all of this under the hood, less sort of sexy front end kind of stuff than AI is going to be. You get that stuff too, and that stuff is kind of more like closer to a guaranteed value than the AI value proposition. But if something good's going to come out of AI, this is how you're going to do it anyway. So that's the selling idea: is use AI to sell your make everything better pitch.